polynomial that has a lot of terms. It has 1, 2, 3, 4, 5, 6 terms. We can't factor it, but we want to find the x-intercepts. So what we're going to do is we're going to start by taking our calculators and typing that polynomial into our calculators very carefully. So take a minute here, type that in, and then we'll talk about where we go from here. Minus 3x cubed. All right, so once you type that in very carefully into your calculator, you should get a picture that looks something like that. So take your time, graph it. So a calculator can be helpful sometimes. We're going to extend this a little bit more tomorrow. We have a nice, pretty polynomial here. And looking at this picture, looking at this graph, you can see that there are three unique x-intercepts, right? Now, we're technically, most of the time, going to trace using, like, the second trace feature. And we'll do that in a second. But for this problem in particular, you can look at your graph and pretty much figure out where the roots are, right? Where do you think they are? Yep, 2, 1, negative 2. And if you wanted, I mean, you could trace it, which we'll remind you in a second, but you could look at your table here and see that, oh, at negative 2, that is an x-intercept. 1 and 2, those are all x-intercepts. So let's save ourselves a little time here, and just trust me that x equals negative 2, 1, and positive 2 are the exact x-intercepts that you can see on your graph. Now, here's the thing. We need to prove that these are x-intercepts. Now, the process we're going to follow here is twofold. First, we're actually going to do an algebraic proof. Right? So we're going to verify that these are x-intercepts. But in the process of verifying that those are x-intercepts, it will get us to the point where I can find some other x-intercepts. Because what's the degree of this polynomial? 5. How many total roots does this polynomial have? 5. There should be 5 roots in this bottom box. How many do I have so far? 3. I don't know 2 of them. I have to get to the point where I can figure them out. So here's how this is going to work. We're going to set up synthetic division. So we'll start with step 1 here. Write all those coefficients along the top of your box. So 1, negative 1, negative 3, positive 3, negative 4, and 4. Now this time, on the outside of your box, let's start with this negative 2. When I put x equals on the outside, you're still going to write x equals negative 2. You're not changing the sign this time because I already gave you the x-intercept. The reason we changed the sign before is because I gave you a factor and you were testing the x-intercept. So let's go through the synthetic division process. I'll go through this one, I'll kind of talk through it, and then the rest of these, I'll assume you know how to do it. So you bring down the 1, and this was on your quiz, so you should be good. You multiply 1 times negative 2 and get negative 2. Then you add those together. What do you get when you add? Negative 3. And then you start over. You multiply again. Negative 3 times negative 2 is 6. And add. You get 3. All right. 3 times negative 2 is negative 6. And you get negative 3. Lots of 3's in this one. Negative 3 times negative 2 is positive 6. And 6. You get 2. Negative 4. And what's your remainder at the end? 0. Now, that's good. Because what does the 0 tell you about negative 2?
It's a factor.
That it's an x-intercept. So we know that one of the roots is negative 2. I just proved it. You did a proof right there.
Wow.
Yeah. It's a little bit better, right? Yep. So here's the thing. We started with a quintic polynomial. And remember, when we do synthetic division, we lower the degree by 1. So what's the degree of this polynomial that I had the coefficients for? X to the 4th. Well, I still have to check 1 and 2. Now you could, to prove that 1 and 2 are roots, you could go back and do the exact same thing from the original polynomial. But the thing is, that's actually not going to get you anywhere. Like, you'll prove that they're roots, but I'm still not going to be able to find the missing 2 roots. So here's what we're going to do so that this actually helps us. We're going to draw, and I'm just going to connect the boxes. We're going to do synthetic division again. And we're just going to continue it. We're going to make like a chain of synthetic division here. So those numbers you just got, those are the coefficients of the new polynomial. So we're going to test, do you want to do 1 next? So let's test x equals 1. So just bring the 1 down and do synthetic division with those new numbers. So 1 times 1 is 1, gives you negative 2. Multiply and add. I'm not going to talk through this one. I'm going to hopefully assume that you can do synthetic division here. And if not, we'll have to work a little bit together. Check at the end, you should get a 0 because we're proving that it's a root. Are we okay here? So we just proved that x equals 1 is a root. And again, this is helping us because if I started with degree 5, I did synthetic division once, I got degree 4. What do these numbers, what polynomial are they for? Polynomial degree, oh, we went 5, 4, 3. All right, we're going down. This is going to help us because we have to check one more. This is x equals 2. All right, so I bring down and do synthetic division again. I'm going to check x equals 2. I'm going to prove that it's root. So last time here I bring down the 1. 1 times 2 is 2. Those actually add up to be 0. 1, 2, remainder of 0. Did you mess up with the 0? It is kind of like binary code. I don't know what it spells out though. Alright, are we okay? So we proved that we have 2 as a root. Jamie, you confused? Alright, we'll let her figure that out. Now, we started with x to the 5th. So I'm running through this again so you get what's happening. I started with x to the 5th. As in my process of the proof, I went x to the 5th down to x to the 4th. Then down to x to the 3rd. What kind of polynomial do I have with these coefficients? X to the 2nd. So, in the process of proving these, I've gotten down to a quadratic. Let's write out the quadratic that you have here. That's 1x squared plus 0x plus 1. That's the quadratic that we've now gotten down to. All right? You do not have to write this down, but let me show you real quick. Based on these roots, here's what we've done. Hold on, just watch. You don't have to write this down, but I'm going to show you where we're at. Based on these roots, I know that I have now a factor of x plus 2, x minus 1, x minus 2, and now x squared plus 1. So we've now factored this polynomial using synthetic division. I still need to find 2 more roots, right? And if I have a quadratic, how many roots is that going to give me? 2. So we're going to set that equal to 0 and solve it somehow. You're going to factor, complete the square quadratic formula, or just solve it. What method do you want to use? Solve it. Just solve it. What would you do? Subtract 1? Right. So if I subtract 1 here, I get x squared equals negative 1. Then you square root. What do I get when I square root negative 1? Plus or minus. Very good. I. Those are the 2 missing roots. Positive I and negative I. Now I have all 5.
After math boundness, I've never.
There's a proof. You just did a proof right there. And there was no columns, there were no words. Yay. At the end of proofs, in math higher up, they do a little box like this, and that actually represents the mathematician who started doing that little box at the end of a proof. It represents, some people color it in because it's supposed to be a tombstone, because it's like the end. Because you died a little on the inside of the proof. Yeah. All right, now let's flip your paper over. We're going to skip the next one, and we're going to do number 3. All right, and then I'll give you number 2 to do on your own. But number 3 we're going to do here together. Start again by graphing this in your calculator. So take a moment, type that into the y equals, you'll get a different looking polynomial this time. 4x to the 4th plus 20x to the 3rd you think it's long typing these in, imagine being the math teachers who had to figure out the polynomials. And multiply all that out. It didn't take a long time. So there's your polynomial. Looks a little different. Now, when I look at this polynomial, how many unique x-intercepts does it appear to have? Just one right now. So let's trace it because it doesn't look like I can just eyeball it this time. I want to trace it. So we'll do second trace. Which option do I choose for root? 0. And then we'll bring our cursor down. We have a enter on the left, enter on the right. So it actually comes down and touches. So it's a little like a parabola there. And where does it appear that that root is? 1/2. Yeah, 0.5. It just rounds the 0.003 thing, which is rounding. So that crosses the axis or touches the axis at 1/2. So let's think about this. If I have a root at 1/2, if I appear to come down and bounce off the axis, what's the multiplicity of that root? 2. So when I do my synthetic division, I'm actually going to have to test and prove that 1/2 is a root twice. Right? Multiplicity of 2. So what's the degree of this polynomial? 4. It's quartic, so how many roots should I get at the end? 4 of them. So let's go through this. We're going to start with synthetic division. List your your coefficients across the top. And we're not missing any, so I don't have to put a 0. Alright, so we're going to test x equals 1/2 to start. Just be careful with your fractions. Bring down the 4. 4 times 1/2 is 2. Add those and get 22. Half of 22 is 11, Bobby. Does that up to 40? 40 and 1/2 is 20. -26, and half of that is -13. Well, that's good. You proved that it's a root. Right? So we know that 1/2 is one of the roots. So I started at x to the 4th. I'm now down to x to the 3rd. I still have to test another root, though. What's the other root you have to test? 1/2 again. So you have to do it twice because it has a multiplicity of 2. So again, just bring it. You can, if you really don't like the whole chain of synthetic division, you can rewrite it every time, but it saves a little time here. So now just be careful with your multiplying again. Bring down the 4, 2, 24. So again, you verified that 1/2 is a double root. There's 2 roots at 1/2. So to recap, we started with x to the 4th. We got down to x to the 3rd. Now we have a quadratic, x squared. What quadratic do I have now that I did my synthetic division? 4x squared. Yeah, plus 24x plus 52 equals 0. Now there are multiple ways you could try to figure out how to solve that because we still need 2 roots in my list. You could try factoring, although I don't know if I want to factor that. Try factoring, quadratic formula, or complete the square. I'm going to do complete the square because we haven't done one together in a while. If you like quadratic formula better, that's okay. But to do complete the square here, can I do that with a 4 in the front? No. So this is a good recap because I think complete the square is going to be faster on some of these problems, at least for me. So I'm refreshing your memory here. We have to have coefficient 1. So we have x squared plus 6x plus 52 divided by 4. I did this last period. Is it 18? 13. I said 18 last period too. I don't know. I was close.
I was thinking that too.
Yeah. Because 8 times 4 is 13. That's okay. So we get to this point. That looks a little bit better. Why am I allowed to use complete the square on this problem? What's true about the middle term? It's even, and you want to use complete the square when the middle term's even, leading coefficient of 1. So, who remembers what you do to complete the square? You subtract the 13. So we're going to move the 13 over. Yep, so what do I replace the 13 with, though? A box. So replace the 13 with the box, and I put a plus box on both sides. And then Jamie's right. To fill in the box, you take half of the 6, which is 3, and you square it. So it'll be 9 on both sides. Now for the left, this factors into a perfect square trinomial, which we always did as a shortcut, because it's going to factor into 2 of the same things. X plus 3 equals -4. 2 more steps. You'll take the square root. Square root of -4 is plus or minus what? 4i. Ooh, 2i. That's okay. And then you subtract 3. And when you subtract 3, it's going to squeeze in front of the plus or minus. Now, if you did the quadratic formula, you will get the same answer. You'll just have to simplify a lot. But those are your 2 other roots that you were missing. -3 plus or minus 2i. There's all 4. So you see what we're doing? We're basically combining solving by factoring, solving by synthetic division, and then tomorrow I'll teach you another theorem. It'll be like 5 minutes. We'll do another theorem, and then we'll be done with learning for the evening. So what I want you to do is there's a problem that we skipped. There are a bunch of problems on the bottom. I saved space by not giving you room to work, so you have to do work on another sheet. However, I would like you to try number 2. All right, you already have space to do it, so no need to get out paper. I will put the answer up here so you can check when you're done. Now, before you start, some of us forgot this on our quiz. Do you have an x squared term? No. So when you do your synthetic division here, what do you have to put in place of the x squared term? A 0.
Oh, I failed the quiz.
So you need a placeholder. So go ahead and try it. Let me put the answer on the board for you, and then there's also problems on the bottom you can do. But if you can get this one, you'll be good. Okay, so the root's here. All right, so I'm going to leave the answer up for you, and then